Hello everybody. Okay, I'm really sorry I cannot speak in Korean. I hardly speak also in English, so I hope that the translation tool will understand my very specific French accent in English. Sorry if you have problems when you see the presentation using the tool. If you misunderstand something that I tell, don't hesitate to ask me any question at the end of the presentation, and I will try to explain it again. You don't have to be afraid if you think you missed a crucial part. Okay, so thanks for joining my presentation. So I'm Sylvain Bauza, as it was already said. I'm a principal software engineer in the company called Red Hat. I'm also the Nova project technical lead, the upstream project that's responsible for computing. And I'm also another contributor from a decade, and I was previously, before contributing, I was previously doing operation things with my previous employer. So this talk will be about virtual GPUs in Nova, and what are the features that we delivered in the previous release, which was Caracal. So virtual GPUs are actually not very new in OpenStack Nova. This is present since OpenStack Stein release, which is now, I think, 4 years ago. You probably already know how virtual GPUs work with Linux. We have a specific vendor driver that you need to install on the host OS, and you also, but this can be optional, you also have to install another vendor driver on your guest. If you don't, then of course you won't access the extra capabilities of the GPU, but you can actually get a PCI device. In order to do it, basically it's basically using a specific new framework from the Linux kernel, which was intended to be doing this kind of SR-IOV feature without having SR-IOV capable hardware. This is called VFIO mediated devices, which is actually VFIO MDEV. So as you see, this is like a file system. This is a file system that gives you a sys file system that gives you a specific capability, and that describes, for example, how many virtual GPUs it can create. The problem, and I will very quickly give you the limitations of that. The problem with VFIO MDEV is that this framework is vendor specific. Even if the interface is open, the driver itself is vendor specific. I mean, every single vendor has to comply with the API, but then internally can do anything he wants. Also, as a result, it's very depending on the product line, meaning that the capabilities will also depend on the implementation of the kernel driver, which can be different based on what the vendor wants. And also, some vendors want to also propose licensing against that kernel driver. So keep that in mind if you want to play their virtual GPUs. The main contributor of the VFIO is nVidia, and this is license-based. But we can discuss that in the Q&A if you wish. So for example, with nVidia, you have different GPU profiles. For a single GPU, you have different types of virtual GPUs you can create. For example, in the example of a T4 card, you can choose in either creating 16 virtual GPUs or only creating one single virtual GPU. The difference will, of course, the difference will be, for example, the frame buffer size, which is different in either you're creating only one virtual GPU or 16. Of course, as you see, the frame buffer size is different. I will just very shortly show you an example of how this works with the kernel. So here, for example, you can see that I installed the kernel driver from nVidia. If I'm using the nVidia tool, I can see that my card can actually create virtual GPUs, and I can list the GPU profiles that my card can support. And every single GPU profile can give me some capabilities, as you see. In that specific example, I can see all the GPU profiles or the GPU types that my card can create. This is given by the file system. And I can also see, for example, the name of the GPU profile from nVidia. And in my specific example, I can see that for this specific example, I am able to create, sorry, this was quick, but for the sake of the demo, I will just show you less quickly. So for example, in that specific example, I see that I was able to create up to 33 instances of GPU, 23 virtual GPUs if you prefer. And in my example, I was seeing different options in order to create. I will continue, and you will see basically the details in the following of the presentation. So how to configure it in Nova? This is quite simple. What you have to do with OpenStack Nova in order to use virtual GPUs with the nVidia driver is to specify a specific flavor where you say, I want to create an instance with one single virtual GPU, and then you have to configure the compute node to say, for example, in that specific example, with the two GPUs having the PCI addresses that you can see in device addresses, I want to use the GPU profile or the GPU type named nVidia-256. That way you configure Nova in order to say, for those GPUs, if you support that specific NVIDIA type, please use it. All the detailed instructions can be found in the link below. So let me give you again another example. So, as you see in my example, I configured all my GPUs to use NVIDIA 256, which corresponds to the type that I wanted, that can create up to 24 virtual GPUs for my machine. Once I configured the compute node, I restarted it. And then, once the compute node is restarted, I can see that the placement API that gives you the inventories of resources that you can schedule, knows that, for example, for that specific machine, I have two GPUs. I have two GPUs that can actually create some resources. And if I describe, for example, for that specific inventory of that specific PCI device, I can see that I can create up to 24 virtual GPUs for that specific type. And as you see, none of them are actually used. As you see, I also modified the flavor in order to ask for a specific GPU. And then when I create the GPU, I can see that this is started. But no, given I created a new instance asking for a virtual GPU, if I'm looking at the same resource provider, I can see now that there is one virtual GPU that is currently in use. And if I'm looking at the libvirt definition of my instance, I can see that if I'm looking at the instance that I created, I'm looking at the libvirt definition, I'm looking at the mdev, and I can see that the instance, the libvirt guest, is using a specific mediated device from that UUID. And if I'm looking nVidia SMI, I see that indeed there is one virtual GPU that's active. And if you see from that VM, using the type that I described. So what I showed to you is present since OpenStack Stein. So if you have a recent release of OpenStack, you are able to use it. No, I'm gonna present you what's in the latest release of OpenStack, meaning that what you will see is new. You will have to upgrade your environment in order to use it. First, what we delivered in Caracal is a bug fix. That's a bug fix because recently we discovered that nVidia modified their own GPU cards in order to propose SR-IOV on their cards. The problem, as you see, is that now, instead of having a GPU only using the kernel interface called VF-IO-MDEV, now it's adding another layer, which is a virtual function. And each virtual function is exposing a number of virtual GPUs it can create. If you read the docs from nVidia, for example, you can see that for a specific GPU card that's coming from the product sheet, for example, for a specific card, it can create up to 16 virtual functions. If you read for the same card, the GPU types it can create, as you see in that specific example, it can only create, for the card, it can only create 10 virtual GPUs, which means that there is a discrepancy in the number of physical functions and the virtual GPUs. The problem is that that discrepancy in between the virtual functions and the virtual GPUs created a specific corner case in Nova that gives you some scheduling errors. The problem is that Nova only knows about the mediated devices. But the problem is that once you create all the mediated devices, then the inventories that's given by the kernel driver changes. And we were considering the inventory given by the kernel driver as being static. Now this is becoming dynamic. In order to fix the problem, we worked around it by proposing for the operators to configure, to say to Nova, to instruct Nova to say how many virtual GPUs that specific type can create. So in that specific example, we are not calculating the number of mediated devices that Nova can create. We are directly taking it from the configuration. So for example, let me show you the corner case. In that example, I'm showing you that that specific card already has 9 virtual GPUs that are created. But if I'm looking at the sys file system, the file system is telling Nova that it can actually create 7 other virtual GPUs. So Nova thinks that that card can still create 7 other virtual GPUs. But once you create another GPU, then eventually all the other inventories change to 0. That is creating a problem with Nova, and that's the solution that we addressed in Caracal. If you say max instances equal to 10, then we cap the number of virtual instances that we create to 10. If you're not using Caracal, this is possible to work around the fix by pre-creating the MDevs. But I won't explain that in my presentations. If you have any questions, let's discuss that in QA or maybe after the talk. Another feature that we delivered in Caracal is vGPU live migration. If you heard the keynote from Mark, he briefly mentioned it in his presentation. So virtual GPU live migration works in the way that you have to have a recent libvirt version, a recent QEMU version, and of course a recent kernel version. If you have both, then basically libvirt will be able to live migrate your instance using a specific virtual GPU from the source with another virtual GPU from the target if they share the same nVidia type. Let's do a quick demo. So in the example that I was having previously, I'm just adding a floating IP just for the sake of testing. I'm just connecting to the instances. I'm running a specific script that will use the virtual GPU. I'm just checking the prime numbers. I will then run the script. You can see that if I'm running the script enough long, then I can see that there is one process that's using the virtual GPU. So now what I'm doing, because of the time I'm directly going to the live migration example, I'm just running, so basically I'm running a script checking prime numbers, and basically I have a workload if you prefer, and then I'm issuing a live migration of the instance. As you see, it's calculating, and eventually, in my next demo you will see it, and eventually the migration will be completed while the workload is continuing to run. So basically, as a reminder, this is possible now to live migrate an instance running workloads, but you have to be careful to migrate your instance quite quickly because of the memory transfer in between the source and the hub, in between the source and the destination. As a reminder, and I will explain that. You will need to ensure that your live migration can complete. If you have a workload that does a lot of calculation and transfers a lot of memory, then your live migration couldn't work eventually. In order to make it complete, and that's due to a limitation with libvirt, libvirt is not reporting us the dirty page tracking of the memory of the GPU. Since we cannot rely on libvirt for telling us whether the migration still needs to copy GPU pages, memory pages, then you basically have to instruct Nova that you have to instruct Nova the downtime calculations in order to make it complete. That's the main limitation at the moment until libvirt will be able to give us some kind of monitoring that we could rely. As a reminder, you also need to have the same mediated device type between the compute nodes if you prefer the same GPU type. And also, that's an nVidia limitation, you need to use the same nVidia version in between the compute nodes. The driver version, I would say. The same driver version in between the hosts. So if you are considering for upgrades, if you are considering the live migration for upgrading the OS, I would say that you will have to first ensure before the upgrade that at least you have the same nVidia version in between both of the machines, which can be a source limitation in some cases. I do agree. One last feature before we are on time is about unified limits. First, what's unified limits? Unified limits is like a cross-project feature from OpenStack, which is currently experimental, where you can define limits of any kind for any kind of resources. In our example, you can define a resource of a virtual GPU, and you can describe the limits of that resource directly to Keystone. You don't have to modify the configuration or the Nova API. You just have to set to Keystone some limitation for the resource. What Nova will do is that it will check the quotas against the limit in order to say whether the user can request the instance. For example, in the case of virtual GPU, that's the setup that I did. I modified Nova in order to use the new unified limit driver. I also modified Nova in order to instruct Nova how to call Keystone. That's why I'm having this specific configuration in order for Nova to know how to call Keystone. And then I then configured Keystone to say, okay, Nova now has the right to read the limitation. And then I'm also migrating the existing limits that I have on Nova. Once I did all the previous steps, then I'm creating a new limit, a new unified limit. For example, in my example, I'm creating a specific limit of X for that specific class vGPU, meaning that, for example, for my user, I don't want to have more than 5 GPUs. If I say 5 instead of X, if I say default limit 5 class vGPU, then each of my users will be limited up to 5 virtual GPUs. And last demo. So, oops, sorry. So that's the configuration that I mentioned. As you see, I configured a specific new limit for my resource vGPU. That's my resource vGPU. I modified the default limit to 1. And then given I was already having another instance using one GPU, that's the example that I showed you before. I was able to create one instance with one GPU. When I wanted to create another instance with GPU, then I got an exception that was saying you're over the limit because you currently have one instance with one GPU, but you're asking for one more. And for that, this is not possible. Again, about the limits, as a reminder, unified limits is pretty experimental yet. So if you want to use it in production, please test it before. You shouldn't be having any problems, but there could be some bugs. So please double check it before with your own environments. And make sure that you create all the requested limits, because if you forget about some flavor kind of resource that your user may request, if you don't specify it, then by default, it won't accept it.